Hello everyone, today we'll be solving the problem number 767, reorganize string, right? So what the question states here, we are given a string s. You can clearly see here, we have been given a string s. So we have to rearrange its characters so that no two adjacent characters are the same, right? So just give me a second, 1 second here. Yeah, we have been given a string s here. So we have to rearrange its characters, right? So just give me a second here, 1 second. Yeah, we have to rearrange its characters so that no two adjacent characters are same. So see here we have a b, right? So these two characters are same, these two characters are same, a b, right? So we have to rearrange these characters so that this one no two adjacent characters are same, so we can just go with the b aba, right? So in this case same goes with the example 2 as well, s equals triple ab. So we cannot do that, we cannot do that, however we try to do, we will get, so here if we put b, this one will be aa, right? So if we try to put b at last, then this one aa, so this is a, then also first two a's will be adjacent. Next, if we try to put the b at the beginning, so this will be b triple a, right? So then also adjacent, right? So this is not possible. In that case, we have to return empty string. In that case, we have to return the empty string. That's what they have shown in the example too, right? So this is the question, man. This is the question. So we have to return any valid rearrangement. So they have not strictly mentioned that we have to enter this itself. So we can return any valid this one rearrangement, or we have to return empty string if it is not possible. Example 2, just now I have explained, right? So each character is a lowercase English letter, and constraints we have been given here, one less than or equal to length of the s, less than or equal to 500, right? And also they have given s consists of the lowercase English letters only, right? So this is fine, right? So very simple question, man. So let's do one thing, let's discuss the approach followed by the complexities, and then let's write the code. First, as usual, let's discuss the approach first, right? So one thing I want to tell you here is we will be going with the max priority queue or the max heap, right? So we will be making use of max priority queue. Max heap is little different, so we can just call heap. Recently we have been making use of the priority queue instead of the custom heap, right? So we are going to the priority queue from many years. So here now we will be making use of the max priority queue, right? So this is nothing but the max heap, right? So this is fine. One thing, let's consider the first example for the approach, right? So first input that we have here is AAB, right? And we are going with the data structure, this one priority queue. So we will be going with a priority queue approach. Let's see the same, right? So first we will count the frequency of each character. So here a is 2 and b is 1, b is 1, right? So a is repeated twice here, a b, right? A is 2, b is 1, the frequency. So now we will push the a and b to the maximum priority queue or the max heap. Here highest frequency list would be highest frequency character would be first, as we are going with the max priority queue, as we are going with a max priority queue. So this one would be, in simple terms, a of 2 comes first, and b of 1 comes next, b of 1 comes next, as we are dealing with the maximum priority queue, right? So this has to be uh, this one, what do we call, within the parenthesis, this has to be within the array. This is fine. So we have to pop, next what we will be doing, we have to pop, or we will be popping top two, nothing but a comma b, a comma b, right? So we will be appending a b, nothing but we are decreasing their count, we are decreasing their count. First a and b will be uh, we will be popping top two, right? Nothing but a comma b, we will be popping a comma b. So I'll just give here pop. So when we decrement, we will be decrementing their count basically. We'll be decrementing the count by 1. A's count becomes 1 and B's count becomes 0, right? So we will push back if it is still greater than 0. If it is still greater than 0. So now what heap is left with a of 1, because we have the 1 frequency 1 still, so A is left still, right? So in the heap, so B has become 0 and we have decremented both A and B, so B has become 0, A has become 1. So this is still left in the heap. This is still left in the heap. Heap becomes A of 1. This is fine. Now what we need to do, we have to pop A. Nothing but, so this one we will be popping nothing but what we will be doing here. Now, we have to append. We have to append. Final string, final string becomes A, B, A. So first we popped AB. First we have popped A, then we are popping A. Here, see here, we are popping A because we have still the frequency of A is still 1, right? Which is greater than 1. So what we will do, we will pop and append that one to the AB that we have popped last. Uh, this one previously, basically, sorry, we have previously we had this one, what do we call, removed AB. Removed AB means we decremented it, we popped from the maximum priority queue and we appended this one, right? So we were left with AB. Now in the maximum priority queue we were left with only A1 because still the frequency still the A, one more A was left, right? So that A we will pop and we will append to the AB that was left. Now we are having ABA. Now we are left with ABA, right? So this is string actually, not in the array. I have mentioned this one in the array. Just give me a second. This is within the strings basically. I have to give double inverted comma here, right? So now we have got the string ABA. So the output that we got here is ABA, which is equivalent to the output that they have given for the this one, example one within the question. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? So this one ABA, yeah, this is fine. The output I mean the approach works absolutely correct in this case, right? So we are completely familiar with the approach. We are completely familiar with the approach. As we are completely familiar with the approach, let's move on with the this one complexities part. So what will be the time complexity and the space complexity here? So the time complexity would be big O of n log k, big O of n into log k, right? So this will be the time complexity basically, right? So what will be the time complexity again? The time complexity would be big of n into log k, nothing but n is nothing but the string length here. N is nothing but the string length here. N is nothing but the string length, and k equals 26. This k we are speaking of. K is 26 and n is nothing but the string length. N is nothing but the string length. This one, n is nothing but the string length and k is nothing but the this one, what do we call, k equals 26, nothing but the distinct lowercase letters. So what would be the space complexity here? Space complexity would be big O of n plus k. Space complexity would be big O of n plus k. In this case we will be going with a string builder of array, string builder of big O of n, and we'll also be considering the frequency array and the heap. We'll also be considering the frequency array and heap or the priority queue. That is nothing but big of k. Overall space complexity would be big of n plus k. String builder of big string builder which is of big of n. And the we'll also be considering frequency array and the priority queue, max priority queue basically. So overall this one space complexity will lead to big of n plus k. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n log k and big of n plus k respectively, right? So this is for the this is it for the complexities part. Now we are completely familiar with the complexities and the approach. As we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the code. Let's start writing the code, right? So the first part here would be we have to count the frequency of each character, right? So this would be int frequency equals new int of this one. Let's pass 26 here. This is fine. We have discussed this one man already. So let's fill the frequency array. So I'll just go with the iteration part here for loop. So I'll just go with character c s dot, let me make use of the operation to char array. This is fine. Within the for loop I'll just go with frequency of c hyphen a, c hyphen a. So this is fine. have to increment this one, right? So we are done with this part. So let's do one thing. Now we have to go with the maximum priority queue or the max heap to store the characters by their frequency, nothing but the highest first. So let's make use of the priority queue here. So this one will be priority queue. Hmm, int, so this is fine as well, and this one is array. So pq, this one equals new, this one is nothing but the priority queue. This is also fine, priority queue. mm, this one will be a comma b, so this is fine. This is nothing but the lambda expression. So this one we are going with the max priority queue just to store the characters, right? Based on their frequency, based on the frequency of the characters, nothing but highest first. Highest should be first. So this has to be b of 1 minus a of 1, descending order, man, in simple terms. So this is fine. Based on the frequency, descending order, frequency of the characters. This is fine. We have already discussed this one in the approach. So exact same thing. Whatever we have discussed in the approach, we are articulating in the form of code. Now let's push all the characters with their frequency into the priority queue. So let me go with the for loop here. Int I equals 0, I less than 26. So let's increment the I. So within the for loop, let me go with the if condition. This one will be frequency of I. So if it is greater than 0, then what we'll do, let's go with the char index and the frequency, nothing but priority queue dot offer. So this one will be new int. This is fine. I comma frequency of I. So this is fine. We are going with the character index and frequency. So let me come out of this one entirely, man. Let's go with a string builder. So this one will be string. So I have said during the complexities part, right? So we'll be going with a string builder. Uh, pick of n. We discussed the same thing, right? So let me go with the result variable here. This one we have to create the instance, right? So I'll just go with the string builder. So this is fine. Let's move on with the further steps here. We have to process the character in pairs, right? So we have to process the character in pairs. Let me go with the while loop. So priority queue dot size. If it is greater than 1, it has to be basically, if it is greater than 1, then we have to go with the most frequent character. I can just articulate in the form of code in this way. This will be int first equals pq dot poll. So this is fine. Next we will be going with the next most frequent character, nothing but, so I'll just go with int. So this one will be second pq dot poll. This is also fine. Yeah, this is fine. Next most frequent character, so let's add the first character and also let's add the second character. So this will be result dot append char. This one, let me go with the first of 0 plus, this one will be a. This is fine. We are adding the first character and the second character. Let me paste it over here as well. This one will be result dot append char. So this is fine. Instead of the first, let me give second here. This is also fine. 0 plus a. So this is fine. We have successfully added the first character and the second character. Now let's write the if conditions, because we have to push back, right? So we have to push back if it is still remaining. We have to push back if it is still remaining, both for the first and second that we have considered. First character and the second character. So here hyphen first of 1, if it is greater than 0, then what I need to do, I'll just make use of the offer operation that is provided by the priority queue. pq dot offer, let me pass first here. So same goes with second as well. So here this one, let me change this one to second, and instead of first, let me pass second here. So this is fine. This is fine. Second of 1, if it is greater than 0, pq dot offer, this remains same. Yeah. Now we are done with this part. We are done with this part. So we come out of this one entirely. So if one character left, then we have to check if its frequency is greater than 1, right? So if one character left, we have to check if its frequency greater than 1, nothing but this is invalid case. So let's write that one. Let's write that one first. So this one will be pq dot is empty when priority queue is not empty. Then let me go with this one, priority queue dot poll, right? Priority queue dot poll, poll operation that is provided by the priority queue. So this is fine. So if it is not possible, then we have to return empty string. Second example, if you remember this one, right? So this one. How can I write that one? If it is not possible, we have to return. So if last one, if it is greater than one, then let's do one thing. Let's return empty string. So this is fine when it is not possible. Then final step is we have to append the last valid character. Just go with result dot append of character. This one would be last of 0 plus a. This is fine, plus a. So we are just appending the last valid character. So this is fine. Uh, the final step is we have to return the final string, nothing but in this case return result dot to string, result dot to string. This is fine. Yep. uh, this is it for the code. Let me format the code once. Let me format the code once. So my mouse is stuck, man. Just give me a second here. Yeah. Let me hit the run button. I hope this works for the test cases, sample test cases. Yeah. uh, this works for the sample test cases, right? So let me hit the submit button. I hope this works for all the test cases, man. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means the verdict that we have got accepted here, right? So now we're done with the solution part, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.